Hi, I'm Miss Everett, and I'm a science teacher here at GWU OHS, and I'd like to just briefly talk about what science experimentation looks like in a virtual classroom, because I feel like a lot of times people forget that we are very busy actively doing science here at GW. That includes science kits and doing lots of hands-on actual science experiments. And it also includes demonstrations that we do with the students, that we provide the students, that we do live and asynchronously, and it can include even simulations that are embedded in our courses, simulations that we do with the students and provide them as extra support. So we are constantly busy doing science here at our virtual school. So first, I'd like to talk about our science kits. And science kits are provided to several of the science courses. Each student is provided a science kit as well as the teacher. And these are huge boxes full of science activities and equipment. So that can include science laboratory safety equipment. It can include chemicals. It can include rocks and minerals and lots of different actual science laboratory equipment. We're talking burettes and beakers and gloves and goggles and aprons and everything you could possibly need for all of the science experiments completed throughout that school year. So some of the science kit experiments that we get to do in some of our courses, one of our favorites are the chemical reactions lab, and we actually do that both with the physical science and the chemistry students. And for this one, they get to observe different types of chemical reactions, observe that process of equilibrium and different changes that they'll see if a chemical reaction occurs or does not occur. So that is one that requires all of the gear suited up and gets to utilize several of the laboratory equipment and chemicals in the kits. Earth science students are constantly using their lab kits. They're doing several experiments, sometimes multiple in a week. They get to identify different rocks and minerals using a massive rock and mineral kit. They're also getting to observe different types of ocean currents and looking at the different ocean densities based on the salinity content of oceans. They're looking at the different angles at which the sun hits the earth to see the difference in absorption of UV radiation from soil to water. We also get to make our own sundials, our own barometers. And then we also see that in the biology classes, they spend a lot of time actually utilizing plants and observing nitrogen fixation in root nodules. They also get to simulate human digestion using different chemicals. So we're very busy with our actual kits that are sent to the students. Along with our kits, though, we also provide lots of simulations, and simulations are sometimes embedded in our courses directly, and they exist as alternatives to the science kits in case there's a student who doesn't have a material or is missing a lab safety equipment. Then those simulations can be performed. But we also find tons of online simulations that are really great at showing the model of an atom, at representing the movement of an earthquake in the crust, at simulating tectonic activity around the globe, the La Nina and El Nina events, looking at different climate patterns or simulating pollution changes, modeling motion and forces and the different physics concepts that exist in our courses. So these simulations we find and we share with the students, and a lot of times we ask them to work through simulations in our live sessions while we model that simulation with the students in that live session. So we do lots of simulations as well. Another area of science activity in real time that we did get to do live are our demonstrations. And our science department loves to do demonstrations. We are constantly doing demos in our live sessions and asking students to join in. Sometimes we make rock candy live. Sometimes we're demonstrating different waves that we see in earthquakes with our arms. Sometimes we are simulating different sound waves, looking at longitudinal versus transverse waves. Sometimes we are simulating density using a density column. We are observing gas laws and placing balloons in freezers, and we are locating the elements on the periodic table, just grabbing materials that we find in our home. Sometimes we're looking at the different physical properties or the conservation of momentum in collisions. And we're doing this just finding materials around our house and asking students to grab them up and model with us. Anytime we're not performing a demonstration live, we're finding other people who perform demonstrations that utilize the same concepts of these content, and we place those into our weekly announcements or share them out to our courses. We also love to do demonstrations and share them in our monthly newsletter. Every month, one of our members of our science department will perform a new demonstration and share it out with all of the parents, staff, and students at our school and encourage them to do that demonstration with us. So yes, definitely we are doing science at our virtual school, and we are definitely hands-on, we're simulating, we're demonstrating, and we're having so much fun. If you have any questions, feel free to reach out, but otherwise, thank you so much for watching.